All right, this is page 8, which is the final page of the main review packet for trigonometry. It starts off, and I'm sure some of you are thinking, unfortunately, with 2 more law of sines and cosines problems. So we're going to do those just like we did the others. Notice yet another typo. That should say km as in kilometers. Anyway, draw a picture, just like we did on the other problems. We have angle A, angle B, and angle C. Angle C is 82.2 degrees. Little c is 7.62 kilometers, which is the side opposite angle C. And little a is 10.9 kilometers. It's the side opposite angle A. So once again, we have side-side angle, which means that this is an ambiguous case problem. Which means if there is a triangle, we have to check to see if there is a second triangle. So we're going to have at least one set of answers to search for. We need to find the measure of angle A. We need to find the measure of angle B. And we need to find the side length little b, which would be the bottom of the triangle over here. So again, we've done a couple of these already. We have to start by finding the measure of angle A, which we're going to do using the law of sines. A over the sine of A equals C over the sine of angle C. So that would be 10.9 divided by the sine of angle A, which we don't know, equals 7.62 divided by the sine of 82.2. Cross multiply gives us 7.62 times the sine of angle A equals 10.9 times the sine of 82.2. I don't like the way that 8 turned out, so I'm going to try to clean that up before we continue. There we go. And we're going to divide by 7.62, and we are going to feed that to the calculator because A is going to be the inverse sine of whatever decimal we get there. Okay? So we're going to feed the right side of that fraction, the right side of that expression, to the calculator. So 10.9 times the sine of 82.2 degrees divided by the sine, divided by 7.62. That is 1.4172114, etc. Now notice that's bigger than 1. Right there, this problem is over because that is not possible. If we were to try to put this into the calculator, it's going to feed us a domain error. This is because, again, just like I said on the previous video, if sine is not between -1 and 1, it does not exist. So no such triangle exists, and we are done with this problem and on to the next one. All right, now this time we have a different situation. So draw the triangle, angle A, angle B, and angle C. Angle A is 39 degrees 54 minutes. Angle B is 42 degrees 32 minutes. Little a is 268.7 millimeters. Okay, so we need to find 3 items. We are given angle, angle, side. So if we look back in our notes for 7.1, 7.2, and 7.3, when we are given angle, angle, side, that is a very simple law of sines problem. So this is a law of sines. This is in section 7-1, law of sines. Anytime we're given 2 angles and a non-included side, that is the law of sines. So we're going to use the law of sines to find the measure of angle C, the length of little b, and the length of little c. It doesn't really matter what order we do them in. I would start doing the measure of angle C first, because that is 180 minus the 2 angles that we know. 42 degrees 32 minutes, which I screwed up, put a decimal point in, so let me clean that up. There we go. And 39 degrees 54 minutes. And again, it doesn't matter if you give me this answer in degrees and minutes. You can if you want to, or you can give it to me in decimal form. Either way, it doesn't matter. So 180 minus 42 degrees 32 minutes minus 39 degrees 54 minutes is, and we're looking at 4 significant figures, 97.57. And I don't know what happened to my pen there. It just screwed up. 97.57 degrees. If you gave that to me in degrees, minutes, and seconds, that would be equivalent to 97 degrees 34 minutes. So I would accept either answer. I'm going to stick with this one. So 97.57 degrees. And if you had 97 degrees 34 minutes, that's fully acceptable. It doesn't matter at all. Okay, so then we need to use the law of sines. So let's say step 2. We're going to find the measure of little b by saying b is to the sine of angle b as little a is to the sine of angle a. That is little b over the sine of 42 degrees 32 minutes. Doesn't look like a 3. There we go. Equals 268.7 divided by the sine of 39 degrees 54 minutes. We're going to cross multiply, which would give us b times the sine of 39 degrees 54 minutes equals 268.7 times the sine of 42 degrees 32 minutes. Then we're going to divide by the sine of 39 degrees 54 minutes and feed the calculator. So we're going to put all this in the calculator, and that is going to tell us what b is. So type that in, 268.7 sine 42 degrees 32 minutes divided by the sine of 39 degrees 54 minutes. That is 283.2 millimeters would be the units. We're going to write those in all the various places, 283.2 millimeters. All right, then the final step, step 3, is to find little c. Which we'll do with little c is to sine of angle c, as little a is to the sine of angle a. That is, little c is to the sine of 97.57. And again, you could substitute in 97 degrees 34 minutes there. You should get the same answer either way. Equals 268.7 divided by the sine of 39 degrees 54 minutes. And we're going to do the same steps we did in step 2. We're going to cross multiply, which is going to give us c times the sine of 39 degrees 54 minutes equals 268.7 times the sine of 97.57. And then we're going to divide by the sine of 39 degrees 54 minutes. I'm going to feed all of that to the calculator to get c. So that is 268.7 times the sine of 97.57 divided by the sine of 39 degrees 54 minutes. 415.2, and that is also millimeters. Now the reason we don't need to run a second triangle check is that this is not the ambiguous case. So there's only one triangle that exists with these measurements. There we are. There's our answer right there, and this problem is over. 415.2 millimeters. All right, that brings us to the last couple problems. These are dealing with Herons formula for finding the area of a triangle with the given side lengths. Herons formula is also found in the law of cosine section, which is 7-3, I believe. Yep, there it is. Herons formula has to do with the semiperimeter. Remember what it says. It says if S is the semiperimeter, which is the sum of the side lengths divided by 2, then the area of the triangle is the square root of S times S minus A times S minus B times S minus C. So we're going to be using that formula, which will be on your reference sheet, to answer the last 4 questions on this packet. This is pretty much all calculator work. So this is a 2-step process. Step 1 is to find S, which we do by doing 1/2 times A plus B plus C. So 15 plus 13 plus 20. We add those up, divide by 2. We get a semiperimeter of 24. Then we find the area. So step 2 is the area, which is the square root of S, which is 24, times S minus A, 24 minus 15, times S minus B, times S minus C. And we just feed that to the calculator, exactly like that. 24 times 24 minus 15 times 24 minus 13 times 24 minus 20. I'm literally just typing it in exactly like it reads, parentheses and all, not even hitting the times button. And that would give us an area of, and it doesn't matter what we round it to, let's go nearest hundredth, 97.49 square inches. And that is how we use Herons formula. So let's do another one. Again, you should pause the video and try on your own before you watch me do it for you. Find the semiperimeter, which means we're adding up those 3 side lengths and we're dividing by 2. We don't even need the equals or the equivalent because it's going to be equals. So 64 plus 88 plus 94, and then divide by 2 is 123 for your semiperimeter. So the area is the square root of 123 times 123 minus 64 times 123 minus 88 times 123 minus 94. So we feed the calculator. And we get that the area is 2,714.01 square meters. All right, there are 2 more of these problems, and then we're done with the first review packet. So here we go. Use Herons formula to find the area of the triangle. Again, same formula. So we start with the semiperimeter, which is half the sum of the side lengths. So we add up the 3 side lengths and divide by 2. Which is 71.135. Do not round that number off ever. So this is going to be a rather long expression. 71.135 times 71.135 minus 22.67 times 71.135 minus 55.24 times 71.135 minus 64.36. Again, we're just feeding that to the calculator exactly as it reads. Don't even worry about how long it is. It's not important. So type that in exactly like it reads. And I am going to go back real quick and make sure I type that in correctly. Before I hit enter, I'm just double checking. And it looks like we are good there. So we hit enter. The area is approximately 609.31 square feet. Final problem. Semiperimeter is half the sum of the sides, 93 plus 30 plus 77. So 93 plus 30 plus 77 divided by 2 is 100, so that's your semiperimeter. Then we're going to use that to find the area. We take the square root of 100 times 100 minus 93 times 100 minus 30 times 100 minus 77. So we do 100 minus each of the side lengths. That's 100 times 100 minus 93. We're typing this in the calculator. And that area is 1,061.60 square yards. That does it for the main review packet. The next video will be on the supplement packet over vectors